Okay, it's 3:30 now, band time. So let's get started on this presentation. This is the future of app development with a common data service that you have chosen to attend today. We will do our best to educate you in this area and answer any questions you may have. So this is all about how you leverage the new SDKs that we are providing. We both have a C# and a JavaScript one, although in all truth this will be more about the C# one, that allows you to write this really performant code based on the data that we store in the cloud, all managed by the common data service. That's what we're here to talk about today. So this is what we're going to run through. We have a few scenarios that talk about where you may want to use this. We will go through the C# SDK. We will show some code examples, and we will do lots of demos along the way. So hopefully we will have a little bit of fun at the same time as going through these complex pieces of code. How many of you are C# experts? Good at C#. Okay, that's about half of you. All right. We will see if we can stretch your envelope a little bit. Okay, so myself, many of you know me. I've been working at this forever. I am charged with dealing with the Dynamics 365 for Operations Development Stack, otherwise known as the AX stack. But now I'm transitioning more and more into the CDS stack as well. I have tasks that I do in the Maker portal that we'll see, and some other stuff as well. So here today, I am pleased to have with me as a co-presenter, Nima. Nima, could you tell about yourself?
Hey guys, so I work on the SDK part of CDS a little bit, and I also work on ALM. I've been working on AX Dynamics 365 for Operations for a while. Happy to be here.
All right, let's do it. So Nima, don't sit down too much because it's all yours.
All right, so we have a set of scenarios that we have in mind when we developed the SDK. The first one that we wanted to tackle was really tightly coupled with Power Apps. So there is the possibility of you writing a Power App against CDS that writes and reads data against it. What we wanted to add was the ability to add complex business logic that you can't really do very easily with Power Apps. So we've added the ability to have this extra piece of code that's written against CDS, and it could be hosted in Azure Functions or any other technology that can host an API, and Power Apps can make a call into that to perform that business logic. So that's one type. The more common type is having some sort of console app or web app or an Azure function that talks directly to CDS to do something. This could be a standalone application, or it could be a service that other applications can call into. Like later on, we're going to show a demo where a phone is interacting with CDS, so the phone can go through this service, which then could go to CDS. So you could have multiple stages there. And the last one is more of an enterprise scenario where you have many systems that are integrating with each other. So we have another component that's responsible for data sync between systems. A few other sessions have talked about that. But with the CDS SDK, we bring in the ability to write additional notifications. Let's say a business event happens to your data. You want to push some data over to another system, or vice versa. You'll be able to do stuff like this.
So consider maybe one of these external systems could be a data warehouse, for instance, that you want updated with copies of your data. And that data can come from anywhere. It can come from Dynamics 365 even, because they are replicated out in our CDS cloud, right? That's a really powerful scenario right there, where the data exists in both places. It's pretty cool. So let's talk about what the SDKs really are meant for. The guiding principle on the design team who built this was very simple. Enable developers, including ourselves, because we will be selling apps with this as well, to rapidly develop apps consuming data in the CDS. That's really all it is. I mean, it's not hard to understand, right? That's exactly what we're here for. So there's some words that we want to dig into. Rapidly develop apps means that the steps until you are getting your feet wet with the apps should be as short as possible. And then there's a performance part of the app when the app actually runs. It has to run as quickly as possible. And especially the last one, we have been very, very cognizant of when we did the design. So the business goals that were set before the group that designed this were, as you see up here. So we had to have a C# API that was great for developer productivity. And that's why I asked about the C# out there, because it is written in C#, the one that we're mainly going to talk about. In fact, these business goals hold both for the C# and the JavaScript one as well. Another goal was that everything that we do in the CDS has to be accessible through these endpoints or through these using this SDK. So this applies to CRUD operations that you do on your data that's in the cloud, but there's also an aspect of where you can modify the metadata or consume the metadata that describes the artifacts that live in your cloud. So both of these things are within bounds of what the SDK is going to do for you. It was designed for excellent performance. When you start using the SDKs, you will notice that this has caused some design decisions to be made for you, and they have been made with that in mind. So there's something we'll talk about, transactions and some other things, and they are modeled in a very specific way to allow you to not fall into some of the traps that we know existed in the X++ world. So those have been part of our goals. Another one is that you can't, for instance, say select star. You can't do that because that's just messy and horrible, and you don't want that over the wire when you only consume one field. Another thing is that we talk about this SDK, then in your minds, hopefully, probably, many of you will think about relational data. And certainly what we have today is very much relational data. We also have some blobs, but it's mostly relational. So, the good old story with tables, with rows, and so on. But that, we're not going to stop there. We're going to add much more to that. We're going to add document databases at some point. We're going to add, who knows, graph databases. The sky's the limit. And when we do, we will add a programming model on top of it that allows you to consume that almost natively. So we're not stuck with the relational model here. We have the ability to do a lot more, bake it into this SDK. And we're already getting there. So those were the design goals. But the architecture of this SDK, there's some important points that we want to make. One of them is that the SDKs that we ship, they're not rocket science. They're really not rocket science. They are intended to be written in a way where they are as simple as possible, and they are a very thin layer over a network protocol that is in effect. So all the SDK does is it creates documents in JSON that are then sent to endpoints, and then the request comes back with a response. We unpack that response and make it into something that's consumable from the SDK. That's all we do. So abstraction-wise, it's a very, very thin layer on top of what we can really do. So just to drive the point home, if you wanted to build an application where you don't want to use the SDK that we have, you don't have to. You can interact with all this glorious data that lives in your CDS without using any of the SDKs. You can just write the JSON documents and fire them with HTTP request against your endpoint. It's pretty cool stuff, I think. Right?
Yes.
Yeah, right. Just terrified you were falling asleep already. Okay. So here's a picture that illustrates what goes on here. I don't have a clicker, unfortunately, so I'm going to point and it's going to be meaningless, but whatever. So you have several cases where you have the SDK, and consider these boxes that are on your left as being the scenarios that we just went through. There was an SDK box on them, right? These SDKs talk to a runtime endpoint, which is just a JSON or a network endpoint with a given port number, right? Yeah. And it talks to the runtime that actually talks to the data layer that actually manifests changes to these different data stores. Right now we have Azure SQL as what we support, but it's not going to stop there. We have document databases that we look into. We have graph databases. We have all sorts of interesting stuff going on there. Because today you can't, in the ERP world that we have today, not everything really fits well in the relational model. Many things are documents that are not easily broken down into the relational model. And instead of pretending that isn't so, we would much rather embrace the change and make sure that we have an open-ended API that allows you to actually leverage that when the support comes. Why don't we take a look at what that looks like? Nima.
All right.
Oh, there's a question? We will cover that explicitly a little bit later.
Actually, right now. So let's do that
okay,
right now.
Let's do it.
Okay. So I'm going to show you guys. Again, this is really hard to see, so let's. This is SDK code. It's a very simple scenario of just doing CRUD on a standard entity that comes as part of the SDK.
Did you turn it on?
Yes.
Sorry.
Can you guys hear me?
No, we're closer.
Better now?
Yeah.
All right, let's go. Okay, so the scenario is for CRUD on a very basic standard entity. And if I were to run this, and for us to try and look at what's happening in the background, that's what it is. So the very first steps that you see here goes back to your question. There is interactions that we're having with Azure AD. So first thing, sorry?
It's impossible to see what's happening.
Okay.
So by the way, what's going on here is that we are showing Fiddler. Fiddler is sort of the man-in-the-middle thing that can monitor all the network traffic. And what Nima is doing is he's looking at that network traffic as it pertains to his little app that he was running at the same time. Is there any way you can increase the font size?
Something we could do is maybe copy-paste some of these things over.
Yeah, that would be good.
So let's do that. This first sets of calls basically are made to the Azure AD.
Remember how I said you would get up closer?
So it's your fault. It's not our fault.
It's my fault, yeah. No, don't do that now.
That's
everything else will mess
that's
up.
Very dangerous. All right, so this is really the call that's being made. As part of the CDS, we're basically taking a hard dependency on Azure AD. So everything that happens in the SDK, all interactions, have a security token included as part of them. So the later call that's going in, again, let me copy paste this one also. They all have this authorization header that goes as part of every request, which means that basically there's no way to call into the CDS without going through Azure AD. Those were the first set of calls that we saw through Fiddler. Second set of calls are discovery calls. Ones to be able that enable you to actually be able to go and find the runtime, a specific runtime instance of CDS that we're going to make the calls against. This gives us a list of all the CDS instances, environments that we have access to, and we use that to find a specific URI of the endpoint that we're going against. Then the next set of calls are really the CRUD calls. So that's really the meat of the business logic. First one is a query call. I don't know if you see parts of it, but it's a query that has a from part, a project part, and a where part. And this corresponds to this piece of code right here.
Can you show it as JSON as raw and then paste it in? So maybe we can see the raw JSON.
I can certainly do that too. So on the code, you see the expression expressed in C#. That corresponds to what's showing up here. So let's do a copy paste of the JSON itself. That's kind of what it looks like. So like he was saying, you could write your own little JSON and fire it with an HTTP call, and you would get the same response, given that you do the authentication things correctly.
So you could actually put this in an IoT device that has string operations where you can do string concatenations where you build these JSON documents. And if they have an HTTP request mechanism of some sort, then you're good, right? You just need to be able to pass in those tokens that you get from AAD. But even that you can talk to through HTTP as well, right?
Exactly.
Yeah.
So there's clients for not just C# but other kinds of languages, JS, et cetera, that do this for Azure AD. You can combine those with your own code in another language and do everything that we're doing here there. Second set of calls corresponds to the code that we have here. So this is a delete.
Could you zoom in a little bit?
Let's zoom in a little bit more.
Yeah, better.
Is that better? Okay, sorry guys. So this delete call corresponds to the code we have here, which is, if we were to copy paste this, another JSON call that has this delete part, and it has information about the specific records we're trying to delete.
Yeah, pretty cool.
Let's walk through another command, which is just to insert. This one's basically a representation of creation of these entities and then passing them through the wire. And that looks very, very similar. I guess that we don't have to go through all of these, but it gives you a better idea of what it looks like. Here we go. Yeah. So
Yeah.
Just to wrap it up, it basically means that everything we're doing you could do with HTTP and JSON, and Azure AD is a really hard requirement that we're having with this. So.
Yeah. So this was built for the enterprise, not for doing Facebook, right? That's sort of the idea. Okay, so let's look at one more thing we haven't talked about yet, which is triggers and notification. Remember in AX, one of the things that we in Dynamics 365 for operations, one of the new things we introduced was that you could listen to events that happened on tables. Remember that? So there you just put in an event handler and you do something when something changes. And that proved to be a very effective model, very useful model to use. And what we have done is we have, in this SDK, we have done somewhat of the same. If you start at the, let's see how to explain this illustration here. Let's say that you're in the bottom CRUD command batch execution there. You do something, you change some records or add some records in the CDS. That goes over to the CDS service that does that for you, but it will know whether there are anyone who wants to listen to those changes going on. And if there are, there's a layer that will make sure that that gets routed back to some C# code that you wrote to actually handle those events. So it's the same sort of abstraction or same sort of model that we use for AX7. It's a little bit harder here because you have the network in between here, and you have to marshal these things over the network, and you have to deal with latency and all these things and make sure that it works that way. We have two concepts. One is called triggers and one is called notifications. Triggers is a concept that is done within the transaction that you're actually executing. So if you wanted to do defaulting on a record, you say you added a field to some entity and you wanted to set that field to a particular value before anything else, then you would do that in a trigger that's run concurrently with your transactions. Of course, you have to make really sure that you don't fool around too much because the transactions will become long and you don't want that. And will probably tear away the feet under you if you don't be careful, if you're not careful. The other case is notifications. So this is sort of more of a fire and forget thing, where we say, yeah, this happens, now go deal with it, and this happens asynchronously, and we don't want to hear about it again, you just go deal with it, it's your responsibility, we don't want to know. And this does not have any impact on the performance of your code, or very little, because it just says, okay, go do it, and I don't care. These things are not exactly done yet. We hope we will have them done soon, we're certainly working on them. But I think it's a very, very useful model where you can be reactive. Say you wanted to build some sort of connector that maintained data in a warehouse made by Oracle or something, some technology, and you wanted to make sure that every time a piece of data was updated, it gets updated in your other system as well. What you would do is you would just wire up event handlers for all the tables you're interested in, and then do simple calls via these notifications into your new system, or into your other system. In fact, that was the scenario that we showed before with the sync, right? So this is a very useful thing. We'll have it working soon, we hope. So keep your eyes peeled for that. So the rest of the conversation today is going to deal a lot with the C# version of the SDK. Why? Because it's simply the one that we have done most work on, and it's the one that I know best. I'm sure that within a few months' time, we will have other people up here who are going to extol the virtues of the JavaScript SDKs, and I look forward to seeing that. But now we're going to focus on C#. So what is it? What can we do? Well, we can do the data access. I'm fed up saying this. Of course we can. We can also access the metadata, of course. And we support these data triggers. So it's a full support. And in fact, a lot of the work, the driving of these features happens through the SDK. So, yeah. Let's consider now what this is. We call it a software development kit and SDK. And it is. It's not just an API. It's not just a set of classes with methods on them where we say, do this. If you call this, then this will happen, and that, and so on. It's much more than that. It's really more like a domain-specific language that's built within C# itself, using some of the really exciting and useful features that C# has. So those features, I've listed some of them. They are lambdas and async and so on. How many of you can stand up and tell me how async works in C#? Wow. Okay. Let me just say that it's a really interesting coding model where you can make sure that you exploit as much as possible without making blocking calls. The compiler does the C# compiler does some tricks behind the scenes where it builds state machines so that the code is re-entrant and so on, so you can get back after you do an await. It's a complex story. It's almost magic what goes on in the C# compiler, but for the user, it ends up being a very, very natural model to use. And for our case, it becomes the answer to our dreams, almost. We use this throughout. Lambdas you all know about, right? Why is it called lambdas? Because of lambda calculus. Somebody said lambda calculus. This was a theory that was formulated in the 50s by Church in Cambridge that talks about the foundations of what functions really are and how you can compose functions. And of course, in Lisp, it's called lambdas. And when C# was made, they said, okay, let's take over that word and call it lambda. They don't actually have the lambda keyword, but they use a fat arrow instead. Anyway, I'm digressing, I know. So it's not unlike Link. It uses some of the same composability features that Link has. I like to call it Blink for business language integrated query. I thought that was pretty clever. I don't know if the team likes it very much, but we'll see. But it is specifically adapted to business applications. Remember I said you can't do select all fields. That's one of them. Another thing is that when you do where clauses and you do comparisons with strings, these are always not case sensitive, whereas Link they would be case sensitive unless you did something else. These are some of the things that you realize as you work with this framework. Now, I have said that all this is good, of course, but there is a downside. When you write your code, you may end up in a situation where the code compiles, but your query doesn't run. We have limited that opportunity to a narrow sliver as we can, but the compiler does not know what backend the capabilities are of the backend. If you build a Link query, you can do the same thing. You can build stuff where it will not actually run, but it will compile fine, because all the criteria that the C# compiler checks are true. Now, if you compare this with let me take a random example, X++, you don't end up in a situation like that. You have in the language itself very, very specific knowledge about what the language stack that lives underneath it can do. So the compiler has a one-to-one knowledge of that. But this is C# and the SDK, and these are disjoint entities. And we're trying to marry the two using this SDK. So this thing can happen. Anyone talking about link will say this outright. And I thought I would too. Am I making myself clear? Good. So let's take a really, really complex query. And of course, this is where you will not be able to read it. But I'll just walk through some code later, and well, you'll be able to see it more. But you have the concept of entity sets, as they're called. The correct term is an entity set is a table, and an entity is a row in that table. We violate that principle a little bit sometimes, but that's in fact the correct terminology. What you do is you get yourself a query builder, then you build your inner joins, and you do your group by, and you notice that everything is done with lambdas, right? Everything here is lambdas. You don't specify select field and then give a field name. No, that would not be type safe. You don't want to give a field name in strings, because the compiler would compile that irrespective of such a field existed or not, and it wouldn't know what the type of the field was. That's why we use these lambdas everywhere, because the compiler will be able to deduct. In this case here, it says i.firstname on this row that you can see there, maybe. That means that you have IntelliSense, you do I and you do dot, and then all the fields will come down, and it knows exactly what fields are there, and it's a syntax error to provide a wrong field. And it knows what the types are, so the type resolution works as you would expect. So that's the sort of the magic that we can provide, and that magic comes from some remarkable decisions made in the C# language that are very, very flexible. One of them is the fact that the var keyword there, it looks so inconspicuous. It's just 3 little letters, var, haha, var. But it really goes much deeper than that. Many of you may think about it as just a shorthand. Instead of writing int, well, same thing. Instead of writing string, which is string, you just do var and just, it knows from the initialization, I don't care. But that's not really it. That's one aspect for lazy developers. But here it serves a much grander purpose. Can anyone see what it is? Maybe you didn't think of this before. It happens in Link as well. The thing is that many of the results of the calls that we make are of types that cannot be described in the language itself. Wow. And that's why we have var, because you cannot write the type in the language. You didn't think of that, did you? People are stunned out there. Okay, let's go to a little bit more of the differences that you're likely to notice. So transactions are not first-class citizens. That means that it is not you. You are not in charge of transactions. Hands off. So all CRUD operations go through these batch executions where you collect whatever you want to do and then say, now go do it. And the scope of the transaction then becomes as short as possible. And you don't send everything over the network in chunks. You package it up and say, go do it, and then give me the results. This minimizes chattiness and transactions as well. There are several ways that these transactions can run. They can run in parallel, where each just runs on its own, in each in its own transaction. You can do sequential, where at least you have some order. And then you can do transactional, where you do sequential, but they're all within one transaction, which is probably the more useful one, I would expect. But this is another change that you have to get used to. Remember how many situations we have in X++, how many best practice rules we have, how difficult it is to deal with transactions and exceptions, for instance. And you have to make really sure that you do the TTS begin and TTS end closely to each other. And what if you call something that calls something that calls something that puts up a dialogue? Well, then the transaction sits there forever until somebody shuts it down. I mean, there are so many problems involved in the way of doing things where transactions are first-class citizens. So we decided, no, we're not going to do that. You take everything you have, you put it together, you ship it out, and it happens. And then when at some point it's done, this is an asynchronous call, of course. Whenever it's done, you come back and you continue. Isn't that what we did with the What was that thing in AX where you could do that? No, there was a, it'll come to me. No. It'll come to me. Suddenly I'll say it and then you'll know what it means. Okay. Senior moment right there. Okay, so we have the normal data types that you would expect, of course, right? Ints, strings, blah, blah, all that stuff. But this is a business thing, right? In C#, there would be no reason to have a predefined type that deals with location or person name or something like this. But in our space, where we're dealing with ERP systems, we deal with locations and person names and addresses and stuff like this, and encrypted strings and pick lists and all that stuff. So we have specific types, high-level types defined for you that can deal with those. That doesn't mean that they are atomic. They are molecular in the sense that you can pick out the individual parts. From a name, you can pick out the given name and the surname and all those things. You can even provide little JSON scripts that can provide extra annotations to each of these, which is pretty cool. So there's other types than you're used to, maybe. So how many were in the last session that Craig did? A few of you. Did he talk about the out-of-box entities? He did, right? He talks about them a lot. And he's right. When you write business logic, make sure that you consider if we have any that fit your need, because it gets much easier if you do. Everything is documented, everything works out of the box. There really should be no reason for you to use anything else. I know that right now, we have in the order of 70 of these, but that number will grow enormously. The latest water cooler figures that I heard was that we would be up to about 500 of these over the next month or so. So I would be surprised if you couldn't find the particular thing that you wanted. You can define your own entities, of course you can, and we'll talk about that a little bit later. I just want to finally say that even if there isn't one that matches exactly, there will be one that matches almost. And then you can always go into the Maker portal and add the extra fields that you need, and your life will be good. So, it's interesting. Take it away. Authentication. In depth.
All right, so we talked about authentication in Azure AD dependency. And again, I'm not going to reiterate, but there's a hard dependency there. But on the other side, when we're authorizing for access, we are using these things called permission sets and roles. So I'm going to show you guys a demo of how you can configure these things. You've seen this before. Power Apps. You can go to the admin center from Power Apps, which takes you here. And for your database, you'll be able to manage and administrate the security of your data. So it's going to come up. What I'll show you is there's a security tab there where you can define roles and permission sets. Permission sets are very similar to what we had in AX. They're basically a mapping of resources.
Could you zoom it? Zoom the screen? Zoom the browser?
I will, yes.
Because it's really hard to read. Yeah, much. Yeah. Getting better. Thank you.
Right, so permission sets are basically a mapping of the resources that are out there, like entities, and actions like create, read, update, delete.
Difficult.
So you can create your own. There's ones that come out of the box with the standard entities. In this case, this one is set up to be able to do CRUD on account contact. Then roles will in turn use these things. So a role will be assigned many permission sets. So let's take this one, for example. This one is assigned 2 different permission sets, and then I can go and assign users to this. the effect of this is that when a user using the SDK or from the portal or anywhere else that interacts with CDS, all these rules will take effect, and we authorize. Yeah, I think that's it.
All right. Okay. So let's dig in a little bit and talk about what this looks like in real life. And since we don't have many different projectors, I have to do this on the same box. So let's just start this. Did you notice what happened there? Did you see a strange white box? You saw a strange white box. I wonder what's going on here. Hello? I really hope I have network connectivity. There. Yeah. The stress we have as presenters. Okay, so what happened here is that you create yourself a client. Now, everything you do in the SDK starts with a client. The client is your authenticated artifact that allows you to actually do anything at all. And you notice that white screen that popped up? That was actually the authentication taking place. Now, I had already authenticated before I came in here just to make sure that everything worked correctly. That's why it didn't come up and actually ask me for my credentials. But if I had not, or if that cache had run out, had become stale, then I would have actually had to provide my username, which is tracked in Azure Active Directory. I didn't have to do that here, but you saw the remnants of this ugly white thing. It's amazing that they can't not show that when it doesn't have to, but I guess that's what it does. Anyway, so let's go in here. Let's just skip over this one for now. Come on. Come on. There. Okay, so now, oops. There. Can you, that's a lot of colors here. Can you read it reasonably well? You know what, I'll give it one more shot here. Whammo. Good? All right. So here's what goes on here. You have yourself a query, and you use this query over the product category. Product category happens to be an out-of-box entity. You create yourself a query builder, and then you start adding stuff to it. So here I am adding a where clause that says this. So what exactly is this? Well, it's obviously a Lambda function. It's a Lambda function from PC, which happens to be a product category. That's why it's called PC in this case. I could call it whatever I want, but I called it PC just for your reading edification. And the expression here is then I only want whatever product category electronics. And I want them ordered by ascending. And again, I use PC here. Again, this is the product category. And the result of the Lambda is an array of the fields that I want, ordered by. Wow, interesting. If you haven't seen this before, it may look a little bit daunting. And then you project, and what you project here is the category ID, the name, and the description. You do select fields on each of these. And again, you pass PC, which is a product category. And notice how, when you're doing this, you can't see it, but the pop-up, the IntelliSense actually shows you all the fields that you need here because everything is type safe and everything is done with lambdas. So in the editing experience and the debugging experience, it works really well, but that's how it is. Can anyone begin to say what happens at runtime in this case? What is the runtime effect of this? Speak up. Yeah, so what happens is that the C# compiler will generate code that at runtime will build a tree that represents this in memory and then pass it to a layer that is within our responsibility that will then reason over it and generate the data access statements that is applicable for the data store that we're working against. In this case, it'll generate SQL that does select category ID, comma name, comma description from product category where name equals electronics, order by category ID. So in this case, you'll see there's a pretty easy pretty easy relationship that holds between the two worlds. So let's see what happens here. F10, there. Now let's start thinking about what the query result is. Now we've just said this is the query. Now we say, okay, when we execute the query, we want the result here. And this is what that looks like. It's an operations result that takes as a generic parameter a read-only list of the artifact that we're going to fetch from the query. And this is where things can become a little bit hairy understanding, because these things, in many of the complex cases, cannot actually be described as simple entities. So that's where you have this case where you are working with types that you can't really describe in the language itself. Anyway, that's for another discussion, or maybe you just don't care. And here, let's do this. So what happened here? We did an await call, and we did execute async on the result of saying, give this query, and this is the query result that we have. So what happens here? Say what? Yeah. So what will happen is that the system will say, okay, I'm going to create myself a delegate that is triggered whenever this is finished. I'm going to spawn it off, now go execute it, and then I'm going to return to whoever called me. And then when this guy is finished, I'm going to execute the continuation where my cursor is now. That's sort of the high-level representation of what the await does. It doesn't do justice to what actually goes on behind the scenes, but you can read up on what that actually does. So let's go on. So there's a for each because this guy, as you saw, here is a read-only list, so I can do for each over it. And if with any luck at all, we will have here a category ID this, name electronics, which was the one that we were looking for, I guess, right? And so on. So it actually nicely did work. There's another situation here that I could go into that has a join of products and product categories, and you do this by an inner join, and the actual wiring of which fields have to be matched is fueled underneath the covers by the relationship that holds between these two entities. So you don't have to specify on category ID equals foreign key or any of that stuff. That is dealt with underneath the covers by our system. I didn't put a where clause there, but that's fine. So again, the same thing here. This is interesting. Here there is a list of tuples of product and product categories. So these are lists of pairs of these two. And let's see what that brings. Mid-range speaker, that's probably true. That's in the category of electronics. Let's see if we have more. Let's see. Yeah, these are all, well, you see how that works, right? Let's see, what else do we have? I think that's about it for now. Yes, sir.
Yes, so there's different modes of authenticating. One is user prompt by Azure AD. One is just user password if you wanted to. This was the user.
Yeah, any other questions about about how this works? This is pretty cool stuff, right? How do I manage custom entities?
Because you have the LSNs for the out of the box.
Yeah, so this is something that we will discuss a little bit later. There's two ways that you can do this. One is you can use a snippet of code that identifies the entity in line. So it's a custom entity, but you define the PO code that represents it, and then use it as if it was any other. And that's what I'm going to show you in a few minutes. The other option is to use something called generic relational entity, which is just a property bag, where you say name value, name value, name value, and you, just like in ADO.NET, you can get a field by its name, and so on. So that's another way that you can consume this with a minimum of actual overhead. Okay, let's see. So where did we end up? Okay, sending info from an Android phone. So let's see if we can get this working. There is a lot of moving parts to this demo, ladies and gentlemen. But here we have it. So this is my phone. Can you see it up there? You can, right? Oops. Where did it go? Hang on. Come on. There. That can't be good. You know what? I'm going to do this one more time. Chrome. As I said, a lot of moving parts. So what I'm going to do now is I'm going to show you one of the scenarios that we've been talking about a little bit before. In this scenario, I have an app that I wrote on my Android. So did you notice I have this guy here with me? You know what that was? That's my band, right? They gave them away almost. So I said, okay, let me take one. And the idea was that my wife was saying that maybe I needed to lose some weight. And I said, yeah, that's true. So I'm going to write myself an app that interacts with this so I can see all my results and so on. And predictably, the result was that I wrote my app and I didn't spend enough time on the treadmill. But that's what happens. So what I did was I wrote a little app, as I said, that will gather information from this guy, present it in a usable form, and then it will allow me to post that information back into CDS. So let's see. I call this app Band-Aid, which I thought was pretty interesting name. And by the way, notice that, yeah, never mind. So this is what it looks like. I have here the beats per minute. I have here the miles per hour that I'm running. And here is sort of an overview of all the data that I'm collecting at the same time.
You're dead.
What? Yeah, I'm dead right now. Yeah, I know. So let's see if we can get this running. So I'm going to turn this thing on. There. And this thing should start registering something. Okay, so remember that I said at one point before that I wanted you to keep the aisles clear in the room. And let's see if I do a little bit of exercise here. What I don't do for this company. Oops. good. So let me walk you through what really happened here. Here. So what went on was that I did an authentication here, and I did it in Android as it happened. Let me see, helpers. There. How can I explain this in a good way? What I did was I reached out to Azure Active Directory, saying, this is me, could you please give me a cookie or a token? And this token, when I have that, I put it into the package that contains the serialized information about my running. So every second as I did my little running down there, I took the biometrics, my pulse and my speed and number of calories burned and the distance I had run. Every second I gathered those. When I pressed the stop button, what happened was I serialized that into a JSON thing. I took that JSON string, put it in an HTTP request, put the token into the header, and sent it over to a little something that I wrote. So that was the sending side. Now let's look at the other side. Yeah. Let's see. Here. So what I did was I wrote an Azure function. Now, do you all know the concept of Azure functions? They're pretty neat ways where you can take pieces of code and have them executed on the network when something happens. It's really a very, very nice feature. There are some issues in how you author these, and this is not really C#, it's C# script, and we're going to have discussions about that, and we'll probably do sessions in the coming months where we describe that a little bit more. But what happens is that this guy gets hit. I take out the security token string here, and I create my client. Remember I told you that you can't do anything without a client. So I take that token string that I got, and I create a client based on that. So the key here is that all the authentication happened on the device. None of it happens on the Azure function. It would have been too easy just to do the authentication here. Okay? And then what I do is I take this payload, which was this JSON document, and I deserialize it somewhere. And then what I need to do is I need to insert a new exercise, and the new exercise has a child as one-to-n relationship with the actual readings, the biometrics. So I needed some entities to describe that. So what I did was inline. This came back to the discussion that somebody down there asked before about how to do this for entities that are not known in advance. So what I did was I created my exercises and my biometrics inline just by doing the same thing that the compiler expects. I put in the properties that describe the strings and so on. I put in the relational field names. I put in the information down here that tells me that the exercises lookup field actually relates to exercises in this particular way here. So that's how it works. And then, let's see. Here we go. You create your new exercise. You populate it with whatever came from the JSON document. And you create your readings. You insert this. What happens here? Nothing. The only thing that happens is that you say, this is going to be inserted when I fire off the batch transaction at some point. Then I go through all my readings. I create a new instance. I populate it here, blah, blah. And then I do an insert for each one of them. And then I do execute async. And then with any luck, I say, OK, I log some data, and that's fine. With any luck, let me just see if I can refresh this. Hang on. Sometimes come on. There. So here you can actually see what it did. Expand. Yeah, so I put in a trace that shows exactly what happened. I was hoping that I could find the actual JSON that I shipped over here, but I got lost because other things, the log isn't big enough to hold it, unfortunately. But at least that's what happened. So, if I go into my, get rid of this, go into my, get rid of that. Here, go into my, and I know you can't see it, but I will. Okay, that's too much. It's also too much. Hang on. I will get there. There. Okay, so let me find my... These are the two entities that I added, remember? By exercises and biometrics. So if I go in here, you will find the same names that I used here in the thing in the code. And if I go to data, you will see that 313 today, 418. Is that about right? So did it actually insert the data? Yes, it did. Whew. So many moving parts. Okay. Right. So what's the status of where we're at this particular point in time? We are churning. We have a team that is working on this, and we have some releases, a private preview coming up soon. There are some things that we don't have yet. We don't have set-based operations defined very well yet. To me, that's one of the greatest things that we have to work with as soon as possible, because there are so many advantages to using set-based operations, because the data backends are attuned to them and do them very, very, very quickly, rather than doing one at a time. So that's something that we have to do. But it's not just, of course, defining the backend. You have to define what the language API looks like for that particular thing. And that's the topic of some discussion now. So, but we'll get there. We have some queries that contain strings that are a little bit limited in their functionality, but it's not something I think you'll notice. The trigger notification scenarios that I talked about, where you could do fire and forget, that was a notification, or the trigger, where you run as part of the transactions, that is not ready at all. We are working on it, but it'll take at least 2 or 3 weeks, if not a month, before we have that done. We have some issues with aggregates as well. We can do aggregates in group by clauses, but we can't do select count star from product category, for instance, to count those. That's, in my opinion, a major oversight, and we'll get that fixed as soon as possible. So, I mean, you don't really care about what we've done and what we haven't done. I know this. I'm just saying this to make it plausible to you so that you understand that we're not ready yet. We don't have the final product yet. And it'll take a few months before we have something which we say is a finished product. There is a private preview coming up where people will be able to use our stuff. And let's not forget that people have, both Microsoft and others, have written production-style apps that work with this. So apps are in existence that work with this SDK to do production work. So we have drawn first blood with this thing, and we have learned a lot from that, and we will continue to learn. Yes, sir?
What's the best practice on having, you have currencies and dollars have one system, USD in another system. You have to kind of hard code that or something like that.
The question the gentleman asked, I think, boils down to, do we have a unit of measure system that will perform automatic conversions between things? So that you can have measurements that deal with centimeters or yards, and when you use them, things will happen automatically? No, we don't have, but that's an interesting thought, by the way. I haven't thought about this. There are several ways that you can do it. I'll think about that, but no, we don't have that.
It's also just, your use case was integrating the whole, right? In one system, the country
No, there's no aid for that. But we should have thought about the unit of work. Unit of work. That was the name of that feature in AX. Unit of work. That's right. That was where you could batch these things together and say, now do it, and it'll do it within this minimal transaction. Any other questions, sir?
When we have large amounts of data to fetch for a read scenario, for example,
Yep.
with millions of data, so I've seen the take and skip in the complex.
Yes.
So what was the chunk size you would say?
You can give the chunk size as you wish. You can say take 25 or take 5,000. It doesn't matter. And it's very now that we work with the Azure SQL database, and it is very, very efficient. It's a great database layer. It really is. Go ahead.
Although I would like to stress that for scenarios where you want millions of rows, there is data import export capabilities that we have separately that you should probably use those to be more efficient. This is more optimized for, let's say, 10,000 rows. Although you could do all of this, it just takes a long time.
I mean, today in production in Dynamics 365 for operations, there are many, many tables that are very, very big, and we deal with those, and you could do exactly the same scenarios using the CDS without any problems, right? So yes, it would just work.
How do you get what you have now, SDK? How do you get that?
We will do a private preview first, and then we'll do a public preview. The actual dates that we will do that, I am not sure I know yet, but we will let you know. And you will be able to download them from NuGet packages and install them that way on your box. That's the way it's going to work. It's not going to be far from now. Don't worry.
So for the private preview, we're targeting around end of Q1, but it's only based on people's interests. So if you're interested, let us know. We might ask you to bring in like a prototype that you're thinking about doing, and then we'll evaluate, we'll discuss as we go.
Is it on GitHub?
It is not currently on GitHub. We're not making any announcements either, but we're definitely thinking about it. You can send us email, either me, Peter, you can send us email.
You mentioned earlier that transactions are batched, and in case with common data services and not the programmer.
Correct.
Like present.
Correct.
But in unit of work, we have exact control as to when to write it to the database. And is it similar to, if I have to draw a pattern in DEV08, if I query the inventory on hand to an AI service, I get more latest information than when querying the backend database?
No, there is no caching involved anywhere. We don't this was a decision that they made also. They don't have layers of caching that they need to maintain that grow stale and all that stuff. No, it does not.
If I have multiple apps that were developed using the same entities, and one of the apps updates the data, and if common data services decides to update it way later,
Yep.
the other application depending on that data.
So there's optimistic concurrency that takes place here, if that answers, just as we did in AX. So you will get to know that changes have happened while you have been doing your update. So optimistic concurrency. Sorry, you had a question down there.
Peter, the SDK enables you to manage multiple CDS environments. Let's say there is 50 different customers, 50 different CDS. Let's say you want to have the same CRUD function operation on all of them. How are you handling the authentication in this case?
Well, the environment that you're working against is part of the configuration of the client. You actually specify to the client which environment are you working against at that point.
But I want to work all the 50 against all the 50, not just one. I want to work against all the 50.
So the client object that we showed, that has configuration tied to it. So if you have 50 objects of type client, then you can do that.
Is there a tool as part of the SDK that generates the local stubs for the entities?
Yes, there is. There is such a tool. We haven't, excuse me, we haven't made it public yet. But what we expect to happen, well, now I'm in trouble if it doesn't happen this way, but I've been fired before. But what will happen is probably that up here in settings or in something called code or SDK or something, there will be a drop-down where you can select a tool and you can give it a name of an entity, and it'll into the paste buffer. It'll paste the definition that I showed you before.
I was more thinking of something integrated into Visual Studio.
Yes.
Like
So
something like the old other stuff.
yeah. So right now we don't have a story for the Visual Studio Pro developer, an integration into Visual Studio. We would really like to have that, but we have to focus on first things first. So at some point, I hope we will have time to develop something where you can, Visual Studio can say connections, and you can get a connection to your CDS, and you can see your entities there. And a lot of the stuff that you see here, for instance, will be possible to do in there, just as you can with raw SQL today. And there, the stub thing would fit very naturally. But we don't have that story yet, unfortunately. At some point, we will.
Do you have support for offline synchronization?
No, not at the SDK level. But what does Lance have to help us there? Does he have anything?
For offline, I think Lance's stuff relates to syncing between systems.
Yeah.
I think what you're describing is on the client having that data cached and available offline.
I see.
If you lose connection,
I see.
which we don't have planned as of now.
No, so the question really is there a way to insert a message queue system, something between your client and your layer that hosts the SDK, something like this?
Exactly, and we have requirements for this from internal teams also, who are trying to use the SDK in an offline scenario. So we're thinking about it, but we don't have any promises to make yet.
I'm sorry I'm doing this, but it's very cold up here, so I beg your indulgence while I do this. Yes? It's all yours.
That goes back to our versioning strategy. So we don't have anything to announce, but we'll try to keep at least one version backwards compatibility. And I think that's included there. These are things that we haven't really gotten to yet. But rest assured, given time going by, we'll get there.
Sure.
Can you talk a little bit about when it's, what's the best strategy to populate the common data service from logic apps and flow versus SDK? When is the best practice to use one over the other?
Well, they're very different things, right? I mean, as soon as you have your data in the SDK, then we will make sure that you can consume it from any number of places. So one example was what you saw with Azure Functions here. We will also have a story with logic apps, where you can do something like, when this record appears here, that triggers a logic app that will send a mail to your manager, or these kind of scenarios, the if this then that scenarios, or any scenario that you would care to put into these logic apps. The short answer is it's all going to work. It's all going to just work. It's going to work with Power Apps. It's going to work with Flow. It's going to work with logic apps. We're not there on all counts. The most aggressive work that we're doing right now is on the Azure Functions, because we think it's sort of a scratch pad for application logic. But all the others, trust me, we will nail them.
What's the recommended client library for authentication? Is it ADEV?
Yes. Well, that's what I used. I think it's probably the only one. But as you saw in my little app here, I did the authentication on the Android device itself. So you can get ADAL libraries for almost anything. Just one more comment on this demo that I did here. One of the reasons I did the demo was that I wanted to learn about Xamarin. And the app that you see here actually works on Windows Phone and Android phones and iPhones. So the investment that you put into writing your app, you get back 3 times. It's really an amazing product. It's a lot of fun. It was a lot of fun to learn how to do that.
Speaking of Xamarin, so I assume you're not going to release that framework for Swift?
No.
Same.
No. So you know what? The getting back to this app. So I was really going to do this to make it a store app called Band-Aid and so on. But then I figured out that the day before that, Microsoft canned the support for these things. So they removed the device from the stores and they removed the API that is needed to talk to the device. So you can't even download it anymore. So I said, okay, I can't sell it. I can't, get $1 billion and buy a chateau in France. So I might as well show it off here at a demo. The story of my life somehow, it's sad. Okay, are we wrapping up here? We have 4 more minutes. Is that right? Sir?
So messages that we saw, the JSON messages to like read and delete, they look similar to the AIF document service. Kind of have like a query that you define a criteria and get back data. We have samples for an update. Does it work the same way? Like you need to get a document hash or something similar before making updates?
So the vocabulary that we use for these JSON documents is our own. We did not, as far as I know, right? We came up with this ourselves.
The patterns may end up being the same because defining a query is almost same everywhere, but it wasn't a goal.
Many ways, yeah.
It wasn't a goal to take AIF and move it.
But is the update operation like that example, we haven't seen it, is it going to be simpler with this?
We tried to make it as simple as possible using the C# SDK. If there was trade-offs that we considered, if you make it really simple, then there's some things that you can't do, the set-based operations, etc. So the patterns that you see, I think, will be there, like the JSON that you saw. That's what we're going for.
Okay, we're going to wrap up now. I see people moving in and out of the room. Let me just say that as a courtesy to the people who have taken their time and to do these presentations and run up and down the aisles and do all this stuff for you, you should probably go and fill out the evaluation forms. It means a lot to us. It convinces our managers that this is worth doing. So please give us your feedback and tell us what we can do better and so on. It means a lot to us. Thank you.